Hi everyone. In this video, we're going to talk about systems of inequalities. So, what is a linear inequality? Well, in our previous videos leading up to this section, we have talked about linear equations and systems of linear equations. And every time we've worked with them, we've always seemed to want to get them in this form, the standard form, which is ax plus by equals c. And all of their graphs have been straight lines. But if we were to swap out, so we no longer had an equal sign and we instead put a less than sign, a greater than sign, a less than or equal sign, or a greater than or equal sign, then that's going to be a linear inequality. So here we have an example. And let me write this using the standard form also, just so that you can see that. So in this case, we have ax, which a is 1 as our coefficient, plus by, which in this case b is 2. And we have that is greater than our constant c. So the only thing that has changed is our equal sign. It's now one of those inequality signs. But we still have x and y are only raised to the first power, and we have a constant on our right-hand side. So to have a system of linear inequalities, it requires that we have two or more inequalities that are working together. So in the last video, when we talked about nonlinear systems, and I said that you only had to have one of those equations be nonlinear in order for it to be considered a nonlinear system. Well, in this case, for it to be a system of inequalities, all of our inequalities, all of our given expressions or mathematical statements have to be inequalities. So, what are the solutions to a system of inequalities? Well, we had talked about our systems of linear equations had solutions that were ordered pairs, so of the form x comma y. And we are still looking for ordered pairs that make our inequalities of our system true, but we're going to have a lot more potentially than we had with our systems of linear equalities. And so in order to find them, it's going to be easier for us to actually graph each inequality in our system, and then we're going to find the area that all graphs have in common, if there is one. And then that area is going to contain our points, all the points that satisfy the inequalities, and we call that our solution set. So the area is our solution set. Now, how do we graph linear inequalities in two variables? So in order to solve a system of inequalities, we need to first know how do you just graph one inequality. And so here we have 3 steps that we're going to follow, and we're going to do 2 examples of graphing our linear inequalities, and then we will go ahead and jump into an example of solving a system of inequalities. So in order to graph one, we need to first replace the inequality symbol. So whether that's a less than, greater than, less than or equal to, or greater than or equal to sign, you're going to replace it with an equal sign, and then graph that linear equation. One thing that's really special about inequalities is the type of line that you use to draw your graph. So if it is a symbol that contains like the equal or equal sign, so like less than or equal to or greater than equal, you're going to draw a solid line. And then you're going to draw a dashed line if the original inequality has just a strictly less than or strictly greater than symbol. Our second step is to choose a test point from one of the half planes. And you'll see what I mean by this as we get into that first example. But you're going to choose a point that's not on your line that you drew, and you're going to figure out, okay, does this make our inequality statement true? If it does make it true, then in step 3, you're going to shade the part of the coordinate plane that point you tested lands in. If it makes it false, then you're going to shade the other part of the coordinate plane on the other side of your line. So let's go ahead and jump into an example. So here we are graphing the inequality x plus 2y greater than 3. And so first thing that I want to point out here is that we have a strictly greater than sign. So that tells me that we are going to be drawing a dashed line. All right, so then the other part of step 1 is we need to replace this greater than sign with an equal sign. So step 1. So here is what we're going to focus on graphing. And to graph this, I'm just going to go ahead and find all of my intercepts. So I'm first going to find my x-intercept, which in order to do so, I need to set y equal to 0. So in our equation, we have x plus 2y equals 3, replacing y with 0. We now have 2 times 0, which is 0, so we just have x on that left-hand side equals 3. So one of the points on our graph is going to be the point 3, 0. Remember, it's because we set y equal to 0, so that's our y coordinate. And then finding our y-intercept, we do the opposite. We now make x equal 0. And so we have our original equation. Substituting in 0 for x, we get 2y equals 3. We want to get 1y, so in order to alter this 2 coefficient, we need to divide by 2. So we get y equals 3/2. So then our other intercept is 0, 3/2. And again, it's because we plugged in x equals 0. All right, so let's go ahead and graph this. So 3, 0 is a point, and then 0, 3/2. So 3/2 is 1/2, so I'm going to put this right in between 1 and 2. Remember, we said it was a dashed line, so draw that. All right, so now on to step 2, we need to choose a test point. And remember, it's got to be one that is not on the line. And so I'm going to pick one of the easier ones to test, which is actually going to be our origin, 0, 0. So step 2, our test point is going to be 0, 0. All right, so plugging that in, again, we're now working with our original inequality, not the equality that we made in step 1. So we have x plus 2y greater than 3, substituting in 0 for both my x and y. And then we need to simplify what's on the left-hand side. So we have 0 plus 2 times 0. Well, 2 times 0 is 0. So then we have 0 plus 0, which is just 0. So is this true? Is 0 greater than 3? It is not. And so therefore, that means that 0, 0 does not satisfy our inequality. And so therefore, we are going to shade the other half. So since our point was on this side of the line, we're going to shade the opposite side of the line. And there we graphed our inequality. All right, now let's go ahead and let's take a look at some shortcuts. I know some of you like shortcuts. So here we have another way that we can graph an inequality without having to use test points. So it really only eliminates that second step from our previous example. And so when you're dealing with a line, so it has to be a linear inequality when you're using this. If we have that y is greater than mx plus b, remember m here is the slope and b is the y-intercept, then you're going to shade the half plane above. If it's strictly less than your mx plus b, you're shading the half plane below. So again, this is just a shortcut. I also want to point out one more time that it's only for of this form y greater than or less than mx plus b. So it's only for linear inequalities. I would recommend that you still use a test point, especially if 0, 0 is not on your line, because that doesn't take too much time. All right, let's go ahead and look at a nonlinear inequality. So here we're graphing y is less than or equal to x squared minus 4. So let's go ahead and follow the same steps. So step 1, we're going to replace our less than or equal to sign with an equals. Another thing in step 1 is, since this includes a less than or an equals in our inequality, that means that we're going to have a solid line when we graph this. All right, so let's go ahead and let's just find our intercepts here. So same thing, let's find the y-intercept. So we have to have x equaling 0. So we have y equals 0 squared minus 4. So 0 squared is just 0, so we have negative 4 on the right-hand side. So here we have an intercept at the point 0, negative 4. And then we also need to find our x-intercept, which is when y equals 0. And so we have 0, which is our y, equals x squared minus 4. Solving for x, we need to undo this minus 4, so add 4. We get 4 equals x squared. To get rid of the squared, we need to undo that with the square root. Remember, we're square rooting to find the value of a variable, so we have both the positive and the negative of that square root of 4, which is 2. So then we also have intercepts at positive 2, 0 and negative 2, 0. All right, so let's go ahead and graph what we have so far. So we have positive 2, 0, negative 2, 0, and then 0, negative 4. And again, it is a solid line. And it is a parabola. All right, so now step 2, we need to choose a test point. And so again, we are lucky, 0, 0 is not on our parabola, so we're gonna test that one. So plugging it into our original inequality, so y less than or equal to x squared minus 4. So replacing y with 0 and x with 0. We have 0 less than or equal to, well, 0 squared is 0, so we just have negative 4 on the right-hand side. So now we need to ask ourselves, is this a true statement? Is 0 less than or equal to negative 4? And no, it is not. Negative 4 is actually less than 0. So therefore, we shade the region that does not contain that point that we tried, which was 0, 0. So we're going to shade the outside of our parabola. All right, so now let's go ahead and put this together with solving a system of inequalities. So here we have the system x squared plus y squared less than 16 and x plus y greater than 1. So very first step, just like we did in the previous 2 examples, we're going to graph both of our inequalities. So remember, in order to graph them, we're going to change these to an equal sign. So we'll graph x squared plus y squared equals 16, and then the same thing for x plus y equals 1. And so If I look at this equation here, x squared plus y squared equals 16, that is the equation of a circle. And so this is going to be a circle that is centered at the origin, 0, 0. And this 16, that's the radius squared. So it's going to have a radius of the square root of 16, which is 4. So let's go ahead and graph that. So we're going to have points, since it's centered at 0, 0 and a radius of 4, we're going to have points at 4, 0, 0, 4, 0, negative 4, and negative 4, 0. Also want to point out, because we need to know if it's a solid or a dashed line that we use, because both of these inequalities are strict less than or greater than, we're going to use dashed lines. And there is my circle. All right, now let's go ahead and do the same thing, but for x plus y equals 1. So in this case, we're going to have, remember to find our intercepts. To find the x-intercept, let y equal 0. And so in that case, you're going to have an x-intercept at 1, 0. And to find the y-intercept, you're going to let x equal 0. So in that case, you're going to have a y-intercept at 0, 1. And so if we graph that, again, we're going to plot this using a dashed line because it's a strict inequality. And there are our graphs. All right, so now step 2, we need a test point. And lucky for us, 0, 0 is not contained on the circle or the line. So we can use that for both. I'm just going to split this up here too. So if we're testing 0, 0 on our circle, remember you're using the inequality, not the equality that we made. So we have x squared plus y squared strictly less than 16. Plugging in 0 for our x and y. Well, we have 0 squared plus 0 squared, which is 0. So now we have the statement 0 is less than 16, which is true. So remember, because it's true, that means we're going to shade the interior of our circle because that is the region that contains our test point that was true. Then to do the same thing for our inequality x plus y greater than 1, 0 is substituted in for both x and y. So now we get the statement 0 greater than 1. Well, is that true? No, it is not. So therefore, we shade the region that does not contain that point 0, 0. So that's going to be above our line. So now we've pretty much done exactly what we've been doing in example 1 and 2, but in order to solve the system, so we need points that satisfy both of these equations, or these inequalities, sorry. And so in order to do so, we're going to need to graph the two of these inequalities on the same coordinate plane. And so you can do this by hand, and I did if you look at my completed resource worksheet online, but I'm going to show you using Desmos. So here on Desmos, I graphed my two inequalities. We have the circle and the line. And my solution set is going to be where these two overlap. So it's actually going to be this part of the circle. and that is the area that contains all points that satisfy both inequalities. And that is your answer. So I hope you found this video helpful, and I wish you luck as you're graphing your systems of inequalities and finding those areas that have your solution sets.